Hello and welcome to our second video for Section 4 of DMA 20, where we're going to continue learning some tools to add and subtract fractions. First of all, one of your instructors let me know that you thought the gentleman in the clip art that I had attached to this slide in our introduction of the videos was me. It wasn't. That's just someone I found in Microsoft Office. This is a picture of me, Dane Peterson, academic coach with TRIO Student Support Services and math instructor for developmental math. So if you ever have any questions about these videos or anything math related, and you see me walking around campus, feel free to come find me. Anywho, on to what we'll cover in this video. Last time, we talked about adding and subtracting fractions with like denominators, finding a common denominator, and adding and subtracting with uncommon denominators. This time, we'll cover finding lowest common denominators with factor trees. So when we have large numbers that it's hard to find a common denominator, factor trees are a good tool to find that. Next, we'll look at comparing fractions, and last, an application problem. Alright, so under our first example, here we want to subtract these fractions and then simplify them as possible, but you'll notice that we've got some larger denominators than we've dealt with in the past, 28 and 21. Now, it might be a little cumbersome to find all the multiples of 28 and all the multiples of 21, and then find the one that they have in common. Most people don't know their 21 and 28 times tables too well. So we're going to use factor trees to help us find this common denominator a little more easily. So first we're going to make a factor tree for each denominator. I'll start with 28. And the number goes at top, and these lines that I have coming off in a V are the branches. The first thing that I can think of that goes into 28 is 2. It's even, so 2 will go into there, right? And 2 times what gives us 28? If we divide those, we get 14. So 2 times 14 gives us 28. Now 2 is prime, so I'll circle that. Okay, but 14 isn't, so we have to break it down more. Again, 14 is even, so I know 2 will go into it, and that's 2 times 7. Okay, 2 is prime, so we'll circle it, and 7 is prime, so we'll circle it too. So that's the prime factorization of 28. We just write the circled primes. 2 times 2 times 7. Next we'll do a factor tree for 21. And 21 is 3 times 7, and both of those are prime. So 21's prime factorization is 3 times 7. Now, we need to find the lowest common denominator. Okay, and we're going to start looking at the smallest prime that we have in either of these lists here and here. The smallest prime number that I see is 2. And then I'm going to compare them. Which one has the most 2's? This one has the most 2's, so I'm going to take the 2's from 28. There are 2 2's from 28, so I'm going to copy those down as 2 times 2. Take both of the 2's because it had the most. The next smallest prime I see is 3, and 21 has the most 3's. It only has 1, so I'm going to take that 3 and copy it down to my list. Then I'm going to look at my next prime, which is 7. Each of them have 7, so it doesn't matter which one I take it from. I just know that since they both have 1, I need to take down 1 7. Alright, and now that I've exhausted all my primes, there's nothing bigger than 7. I'm going to start multiplying from left to right until I find my LCD. Okay, so first I'll do 2 times 2, which is 4, still times 3 times 7. And then I'll do 4 times 3, which is 12 times 7. And last I'll do 12 times 7. You can do that off to the side if you need to. That's going to be 84. So now I know my common denominator is going to be 84. So I'm going to redraw my old fractions with a denominator of 84. Now I need to figure out what I need to multiply my original fractions by to get a denominator of 84. So I need to figure out what 28 times some number will give me 84. I could do some long division if I wanted to, but factor trees are helpful for this too. I'm going to look at my list of primes for 28 and my list of primes for the LCD. I've got the 2's in common, another 2 in common, and the 7 in common. The only number in the LCD that isn't in the list for 28 is 3, right here. It's got the 2, it's got the 2, it's got the 7, but it doesn't have 3, so that's the number that I need to multiply my original fraction by to get that common denominator of 28, or of 84. So I'm going to have to do 13 times 3 and 28 times 3. You can check if you want, but 28 times 3 will give me 84. Same thing for 21. I need to figure out what I need to multiply 21 by to get 84. If I look at my list of primes for 21, I get 3 and 7. And if I compare that to the list in the LCD, I've got the 3, I've got the 7, but I don't have these two 2's. If I multiply these two 2's together, I get 4. That means I have to multiply 21 times 4 to get to 84. So the top gets multiplied by 4, and the bottom gets multiplied by 4 to get equivalent fractions. Now, I'll go ahead and do that multiplication. 13 times 3 will give me 39. And then on the top, and the 3 times 28 we know will give us 84. Second fraction, 1 times 4 is 4. And then 21 times 4 will give me the 84, and you're welcome to check that if you like. So now I can subtract these. 39 minus 4 will give me 35, okay, over 84. Now I need to see if I can cancel out any common factors here. I know that 35 equals 7 times 5. So the only thing that I could possibly cancel with the 84 would be a 7 or a 5. I know that 5 won't go into 84 because 84 doesn't do a 0 or a 5. But let's try the 7. Okay, I'll do 84 off to the side here, divided by 7, and see if it goes in evenly. If it does, I can cancel it. 7 will go into 8 one time. 1 times 7 is 7. When I subtract those, I get 1. So now I'll bring down the 4. 7 will go into 4 two times. 7 times 2 is 14. And when I subtract those, I get 0. So once I'm finished dividing and I have no remainder, 7 will go into 84 evenly, right? 7 times 12 will be 84. Now I knew this before, but I just wanted to show you how to do this if you didn't recognize it. Since 7 was a factor in the list of 84, I knew that 7 would go into it evenly. Okay, but if it's not so apparent, then you'll have to do some long division, like this. So that means I'm going to divide the top and the bottom by 7, since they had that in common. So 35 divided by 7 and 84 divided by 7. I know 35 divided by 7 is 5, and I just did 84 divided by 7. That's 12. And now my fraction is completely simplified. So 5 is prime, 5 won't go into 12, I'm all done. 5/12 is my answer. So to review this problem, factor trees made this really easy to find the common factor, and also what number we had to multiply our original fractions by to get those equivalent fractions. Now we're going to look at comparing fractions. If you have a question like this where you need to compare fractions and find which one is greater or which one is smaller, or put a fraction in order, a list of fractions in order, what you're going to need to do is find common denominators for all these fractions, and then write the equivalencies. Let's practice those factor trees again really quick with these smaller numbers. Hopefully that'll drive that home. We'll start with 6, okay? When we do a factor tree of 6, we get 2 times 3, and both of those are prime. Next we'll do 8. 8 is 2 and 4. 2 is prime. 4 is not, so we'll factor that down to 2 times 2. So we get the prime factorizations of 2 times 3, and we have 3 2's with 8, so 2 times 2 times 2. Okay, now to find the LCD, we look at the smallest prime, which is 2. 8 has the most, so we take all of its 2's. We take down 3 2's. And then the next prime is 3. 6 is the only one that has a 3, so we take it from there. And there are no more primes to look at. So the LCD is going to be 2 times 2 times 2 times 3. And if you do that, multiply that out as 8 times 8 times 3, which is 24. Now, we've got our new denominators of 24. And now we need to find the equivalencies. 6 times what will give me 24? Well, 6 times 4 gives me 24. So I multiply the top and the bottom by 4. And then 8 times 3 will give me 24. So I multiply the top and the bottom by 3 there. So to find those equivalencies, 5 times 4 will give me 20 on top of the first fraction. And then 7 times 3 will give me 21 on the top of this fraction. So now that we have the same denominator, we just compare the numerators, the tops of these fractions. 21 is bigger than 20, so this second fraction is bigger. So we could say 5/6 is greater than, or less than, 7/8 because the second one is bigger. We always open to the bigger fraction and point towards the small one. Finally, it's time for an application problem to round out this section. A truck can safely carry a 1-ton load. Should it be used to deliver a 1/2 ton of sand, 1/3 ton of gravel, and 1/5 ton of cement in one trip to a job site? So is this safe? To find out if this is safe or not, we need to add all these fractions of a ton together. And if that's less than 1 ton, well then yeah, it's safe, because our truck can safely carry one load. But if it's going to be, if we get an improper fraction or a number that's bigger than 1, then that would be unsafe. That would be over a ton and not a safe load to carry. So the 3 fractions that we need to add together are 1/2 plus 1/3 plus 1/5. Okay, now we need to find the common denominator. I'm going to make just lists of 5s, and we're going to find the first one that 2 and 3 also go into. It's good to start with the larger number if you're making the list. So 5, 2 won't go into that, 10, 3 won't go into that, 15, 2 won't go into that, 20, 3 doesn't go into that, 25, neither goes into that, but 30, both 2 and 3, and of course also 5, will go into this number. So 30 is going to be our common denominator. So what do we have to multiply? 2 times 15, also the top times 15, 3 times 10, same on the top, and then 5 times 6. Those will give us all denominators of 30 and equivalent fractions as well. So the first one, 1 times 5 is going to be 15 over 30. Plus 1 times 10 is 10 over 30. Plus 1 times 6 is 6 over 30. So remember, we're going to add the numerators, 15 plus 10 plus 6, and keep that same denominator 30. So 15 plus 10 is 25, and then 25 plus 6 will give me 31 over 30. Okay, so we ask ourselves, is this smaller than 1 ton? No, because it's an improper fraction. This is going to be a little bit over 1 ton. Not much, but 1/30th over a whole ton. So this would not be a safe load to carry with this truck. So that's it for section 4. In the second part, we covered finding LCDs with factor trees. We showed how we could compare fractions to see which is bigger or smaller, and we also did an application problem with adding fractions. Up next, we're moving on to a new type of fraction, mixed numbers. We're going to explore how to multiply and divide mixed numbers in section 2.5.